Spoiler alert, internet drops every 3 minutes on average on roads and rail.
Hello, everyone, and welcome to Inside Stellar. By now, you know, at Stellar, we offer perfect internet for moving vehicles and for ubiquitous devices. We combine all cellular, Wi-Fi, and satellite networks into a single unbreakable connection. With this podcast, we want to bring you behind the scenes to take a look at how we close deals, we perfect our tech, we run our operations, and pretty much anything else we can think of. I'm Simone. With me, you can see Natalia and Dursun, and I welcome you to this new episode.
Hi, everyone.
So today we're talking about how bad is bad internet. And I think we all experienced it ourselves, whether it's on trains or in a car or anywhere where there's drops at any point. So we often talk about experience on the train because we know that it's impossible to stay connected. I think Dursun, you know this very well when you travel to events and you're trying to work on the train without our global, it's basically impossible. How do you experience it?
From what we know, the stats tell us that every 3 minutes, internet drops on European and American roads and rail. And that is significant because if you are thinking about having an important call while you are traveling on European trains, it's basically impossible. Every 3 minutes, you will be cut off by internet. It is important because I think we need to understand why ubiquitous, seamless internet connectivity is important in the first place, right? Especially on the roads while we are traveling. There are so many amazing use cases that are coming up, be it autonomous self-driving cars, for example, right, that we talk about. Think about if your remotely controlled car, for whatever reason, disconnects for even a split second, what kind of negative consequences that may lead to. Or think of another example, emergency services, right? When emergency vehicle picks up a patient whose life is in danger, thanks to connectivity, often these cars are connected. They share telematics data. The devices are connected to the hospital, and doctors can remotely guide paramedics on the spot. So this can be a life-saving situation for the patient. And also another example is traffic lights, for example, right? Traffic lights, traffic management systems are also connected. And in this situation, if it is very urgent case, you can control the traffic lights to give the green lights to the emergency vehicle in order to save lives. So I think this is a clear illustration of why seamless connectivity is important. It's not only important for us when we travel and train and we're trying to get some work done, but it can be a life-saving innovation.
Yeah, and
Exactly. I
honestly,
think,
there is a lot more frustration, I would say, on the business side rather than on the consumer side. On the consumer side, we almost got accustomed to the fact that stuff doesn't work. We just give up, right, as consumers. Businesses cannot. You mentioned a lot of use cases, but there are infinite of them. Payment systems, EV charging stations, security cameras, all of those things. When they go offline every 3 minutes, on average, when on the move, or when stationary, they go offline not because they're moving, but because the networks around them fluctuate. Those are operations and companies, therefore, that cannot process payments. We've had a lot of discussions at the last events and with some of our current customers with complaints that they had to deal with before switching to us when their customers were actually calling their support system because they were having their car being charged and the actual approval of the charging was not capable of being given because the system was offline for 40 seconds every 3 or 4 minutes. And so we needed to work quite a lot to solve it, but I can see how many use cases there are. If we want to even shed some light on a specific, more fun, let's say, use case, it's what happened at one of the last events we attended, when because of congestion, companies that were demonstrating their solution, they were not capable of actually demonstrating anything to the visitors at the event. And so I went to that company and I said, okay, let's make it simple. I give you now cards that will solve this problem. You'll have roaming, priority access. You'll have every ability to navigate through these congestions and connect your devices. Once you tell me that it works, test it for the whole day of tomorrow, showcase your solution to the customers. Once you tell me that it works, at the end of the day, we sign the contract. And they agreed. And this was a super fast switch away from a supplier that just wasn't necessarily bad. It just didn't work well enough.
Exactly. I think you said it really well, where for personal, normal users, it's frustrating to not have internet. And I think I didn't realize how much I accept the fact that I can't take internet for granted on the move, because when we were mapping the roads to find the statistics, like you said, Dursun, every 3 minutes internet drops, and 40% of roads have poor internet connectivity. When we were doing that mapping, I was in the car and we were trying to get in touch with you, Simone, to update you on our journey. And the number of times that the call dropped was insane. Like, we could not have a proper conversation, even on the highways, not only on the small roads where we were following the Tour de France, but also on the highways. And that made me realize just how much I find workarounds, or I accept the fact and prepare for the fact there will be no internet. And for me, it's just an inconvenience. But for all the use cases that you were mentioning, Dursun, like the emergency services, blue light services, all the other services that rely on connectivity all the time, it's critical. And it also means that all of the innovations that are coming to the market, they need to rely on the internet that is always available in order to give the optimal access, but also just to work at the end of the day.
And you see, Nati, maybe we can give context to the listeners or viewers, depending on where you are accessing this podcast. The mapping you're talking about is Tour de France 2023, which was one of our first mapping experiences in which we actually wanted to quantify the problem, the magnitude of the problem. And so when you came back and we got the 3,000 kilometers overall mapped, and we saw that for 40% of the time, broadband internet was not possible. We thought this must be because of the mountains, because of the rural roads and all of that. But then after that, we mapped other hundreds of thousands of kilometers over the years. So we have a big part of Germany mapped, we have France, we have Luxembourg, we have California, New York, Texas. We had, let's say, hundreds of thousands of kilometers of roads and rails mapped. And that stats didn't move. We're still anywhere between 37% and 45% of non-possible broadband access when mapping roads. So for me, it's shocking. I was hoping it would be because Tour de France that year was on the mountains, but it almost didn't change anything.
Yeah. So anyways, we know internet is really bad. We have it in statistics, we have it also in our experience, and we hear it from the customers as well. So let's talk a little bit more about what Stellar is doing, what solutions we are bringing to the market to do something about the fact that internet is so bad.
So maybe one approach that we can take is to go a bit generic, and then we pick one solution and we focus on that, maybe for the sake of this
Amazing.
podcast, at least for this episode. Then we'll see what to expand other solutions and other episodes. But overall, as I was saying as an intro, we connect all cellular Wi-Fi and satellite networks. In practice, how do we do that? We've built a software, we call it Steer. And this software has the ability to fundamentally do three things. We call it seamless switching, dynamic aggregation, and active prediction. Seamless switching, it means that our software can jump from one network and one technology to another, so cellular, Wi-Fi, and satellite, and back, without session loss, in fact, without any session drop. Dynamic aggregation, it means that our software has the capability of controlling more than one line, more than one link, to combine them together into, let's say, a higher, a more performant, and for sure more resilient connectivity for the customers. And the third thing is active prediction. Active prediction is much more of our constant work in progress. We use right now a fairly light AI-powered solution for predicting the next best networks, but we are going to be having quite a lot of efforts over the next 2 years devoted to building the most advanced network predictive engine in the world. We'll have probably another episode dedicated to that. But in practice, once we take this software, we occasionally give it to our customers as a software running on their devices, but more frequently than not, our customers want a very actionable solution that doesn't require much of an integration, even at software level. So typically we take that software and we put it into our SIM cards that have the ability to be the fastest switching cards in the world. As we realize that in order to solve the connectivity issue, launching another infrastructure makes relatively very little sense. What we need to do is just using and leveraging all the infrastructures seamlessly. So we have SIM cards that can switch from one network to another in the fastest way among every other solution in the world. And then for customers that have use cases that are more demanding, and maybe we can focus on this one for now, we have GLOBBLE. GLOBBLE is our smart router with multi-modem, multi-network access, so multi-cellular, multi-Wi-Fi, satellite protocols on board. You just power it up, and 3 minutes later, you're connected to the internet. I have a GLOBBLE that I can even take and show if we want to put it in context. This is the object with the version with detachable antennas. We call it GLOBBLE Regolith. And this has the ability, once you connect it to the power, to basically be online within a couple of minutes. Typically 3 minutes is the connection time. Yeah.
So let's take the global for today because it has both the steer on board as well as our M2M solution. So it's really the all-inclusive solution that we have. And what sort of companies get in touch and for what sort of use cases? We go to a lot of events, we get a lot of inbound leads where companies express to us their challenges. So let's dive in a little bit deeper where global gives the most benefit.
So Dursun, maybe you can start with a couple of examples. I have so many in mind that it's easier if you start.
Yeah. Maybe I will share one specific example that we recently got a request from a company who is in charge of organizing the Winter Olympic Games. So, Winter Olympic Games happening next year in Italy, northern Italy. And it's an amazing, beautiful, but also challenging terrain. And when they reached out to us, they were very clear in terms of the challenge. So they wanted to provide internet access to the staff, organizers of the event, to provide internet connectivity, also to manage parking spaces, to provide access to the visitors, but more importantly to the staff who is behind the event organizing. And they were very clear they wanted a solution that could work up 3,000-meter altitude in minus 20 degrees. And they also wanted it to have a wide radius of coverage in terms of providing connectivity. So we offered them actually the global regolith that Simone just illustrated, showcased, but more advanced version, I would say, because we have also satellite partners, as we've mentioned, right? So we have global regolith with satellite connectivity. We call it global orbit. So this is the solution, for example, we provided to the customer. And the cool thing about it is, yeah, Simone has already mentioned it has two of our multi-operator SIM cards on board, each of the SIM cards connected to different operators at all times. But then there's also satellite connectivity to ensure that in case cellular connectivity drops, there's always a fallback option. So I think this also illustrates the use case where our global enables smooth operations thanks to seamless connectivity it provides.
I was distracted because we just got the contract signed, so I got the notification. But so going on other use cases, I should build on that, where specifically with global. One use case that I can certainly think of is river cruises, or often freight cruises as well, freight transport, let's say, on inland rivers. Often the borders between countries are actually defined by the inland rivers. And so what is happening is that the boat is actually moving in the no man's land, and so it's not always connecting to a network. So typically we take a global, we lock one modem onto one network of one country set of networks. We take another modem, we lock it onto the other country set of network, and overall you always get with quite of a decent, more than decent, I would say, connectivity for the use case. Another use case that is very like near and dear to me is for firefighters and ambulances. We have a lot of deployments for those as well, where to Dursun's point, we're actually having our global orbit deployment, so the global regolith that I showed you, plus satellite connectivity, multi-dome cellular antennas. So if we go very, let's say, descriptive into what the use case would be, is that let's take firefighter, for example. Their operations need to be coordinated and interventions need to be coordinated. And it always starts with a fire truck being at a deposit or at a station, at a fire station. And so when the fire truck is at the fire station, our global device connects to the Wi-Fi of the fire station. When the fire truck leaves, then it connects, depending on whether it's urban, suburban, or rural deployment, to a different percentage of cellular versus satellite, or both in aggregation, or one of the two and using the other as a failover, so that in any case, the fire truck is always connected throughout the intervention, is directable from remotely, and the crew that is on board, the team that is on board of firefighters, has the ability of always using basically unbreakable internet at any moving speed or driving speed. The reason why I'm saying that we don't know a priori, and that's also why you need a very good software on board of a device, is that we don't know a priori how much satellite versus how much cellular is used, is because our customers have ubiquitous deployments by definition. In fact, every connectivity use case is ubiquitous by definition. And in a city, you may be thinking that having, let's take Starlink or OneWeb or any other satellite solution could be amazing. But in reality, because of the shielding of the visible sky, because of what is called the urban canyon effect. So you have buildings, right? So the satellite antenna don't necessarily have a direct line of sight towards a satellite that is obstructed by a building in the middle. You end up being pretty sure of the fact that you're going to be having satellite connectivity in an urban environment maximum 30% of the time, which means that at least 70% of the job or the work will need to be done by cellular networks, terrestrial networks, not necessarily cellular, sometimes also Wi-Fi hotspot, depending on the use cases. While if you are in a more rural environment, where you have an easier access to an unobstructed view of the sky, satellite becomes actually very resilient as a connectivity, often more resilient than a single cellular interface. In our case, we have multicellular interfaces, with each interface connecting to all of the networks in any country with roaming priority access. So we have a bit less of that challenge. But a lot of our customers that come out of a current supplier, and they're like, I'm using a single operator, or I'm using a multi-operator with no real access priority to the networks, they feel very lost before coming to us.
So I think these examples provide a perfect illustration of our global, but I can almost hear some of our listeners asking the question, but at what cost does it come, right? Because it looks like global can provide ubiquitous, seamless connectivity, combining cellular, Wi-Fi, satellite options. How does it compare to competition? Where do we stand in relation to the competitors? Who else is in the market, right? So maybe we can elaborate on that.
And it would be a very good question, by the way, if they ask that, or if they're whispering that while listening to this. It'd be a very good question, completely fair. But let's start directly with cost. So we end up being typically between 3 and 20 times cheaper than competitors on the market. There are macroscopically 3 big competitors on the market. Everyone else is more of a forced type of solution that requires a lot of patched devices in order to reach what Global is capable of doing. The 3 competitors on the market, which are all 3 non-European, which is also an important point, they end up being significantly more expensive than us for fundamentally one reason, and I'll say these reasons immediately after having said that. The price of our global starts from the global black version is 450, the global regular, it's simple with a setup of the software of a specific type is 550. It can increase, but typically the price that you should have in mind is around this one. Now, when we talk about our competition, and maybe we can give this as a tips and trick to the competition as well to make their things cheaper, is how can we make sure that our global is affordable, considering that it has multiple modems inside. Maybe we should share what's inside the device as well. But the reason why we are more affordable is because we didn't start from the hardware, we started from the software. We designed our software for the automotive sector, and in the automotive sector, especially now with electric vehicles, energy consumption and power requirements is vital. Electric vehicles are sold based on design and range. And so everything that touches or affects negatively the range is a cancer to be avoided. That's the reason why our software needs to be extremely lean. But the result of having a software that is extremely lean is also means that when we had to encapsulate it onto smart routers, we could actually pick very affordable pieces inside, very affordable processor, very affordable for CPUs and all of that. And that's a result why we can position ourselves from 450 euros for a device. So do you have a global, I have a global regular, do you have a global black with you so that
I
we can
do.
actually show?
So using Global Black, maybe I can briefly demonstrate what's inside because both of our globals have similar structure. So they come with 2 cellular modems, 2 Wi-Fi modules, and several LAN and WAN ports that are reconfigurable. And there are also number of satellite protocols from our satellite partners. And you can also see DC port for powering. And all you need to do actually to turn it on, just plug it into the wall or 12-volt cigarette port or USB-C. And the other thing that you might notice, there is no on and off button, which is on purpose because the whole idea with our global is to be plug and play. You plug it, within less than 3 minutes, you have internet. You don't know how or why, but it magically happens. And the other cool thing, I think, because it has so many it takes various networks as an input, you as an end user, you don't really care where it's coming from because it provides you a single point of connectivity. And especially if you are moving from, let's say, from your station where you use Wi-Fi, then you go to the road, then you switch to cellular, and maybe in a remote area you switch to satellite. But the output for you as a Wi-Fi connection point doesn't really change. It
It's
doesn't
always the
matter.
same hotspot. Yeah, it's always the same
Yeah.
hotspot. You're right. There is maybe another thing that we can say, because there's our software on board of that object that you showed, of the Global Black, same for global regolith and orbit versions. Our software makes sure that the cellular modems are never going onto the same network, because our cards can go on every network anyway. And so we ensure, let's say, network resilience, internet resilience through network diversity, to make it like a mouthful of an explanation. What I can share, however, is one surprise if we're talking about use cases for how bad is bad internet on the road. So there is one surprise use case that we had when actually going to a customer. Not true. The customer came to us asking for another thing, and then they saw Global and they onboarded it for a use case that is not moving whatsoever in the city center of one of the European capitals. And yet they decided to use Global for their connectivity. um, is traffic totems, I think it's called in English. So those locations where you go at, let's say, bus stations, tram stops, or other stations in the city, in which you have an interactive map that tells you where the next bus, when the next bus is coming, where it's going, and all of this. They were using a single modem from one of the usual suspect single modem suppliers. And the problem was that the single modem was not capable of retaining the connection and, let's say, fight congestions, find network fluctuations, and all of that stuff, which are some of the main reasons behind bad internet on road. And so when then they tested our solution, they decided to adopt it for those totems. It's in Brussels, because dual modem, multi-operator, coordinated by our software. It means that they don't even need to have Wi-Fi inputs or satellite inputs. They just needed their architecture to go resilient at a very acceptable price. Let's put it like that.
Exactly. So since we're already talking about the two modems and the importance of them, let's dive a little bit deeper into the tech behind it. Why do the two modems help in connectivity? Why can't it just be one?
Okay, let's use hands. Modem 1, modem 2. Modem 1 is cellular. Let's talk about cellular for now, because for that we have two cellular modems. Modem 1 is connected to cellular operator 1. Modem 2 is connected to cellular operator 2. So already there is a statistical, I wouldn't say certainty, but a statistical high likelihood of the fact that not both networks will drop at the same time. And so when we're moving around, or when the networks fluctuate, realistically, these two signal levels will move. At some point, one of the two will drop. When it drops, this modem here will be searching for the next network to connect to, ensuring that it's not the same network where this modem is connected, right? So then we bring up this network, and then eventually this one will be falling, or this one will drop again. And so it's a constant dance of basically ensuring connectivity. The reason why that dance needs to happen is because while we have light predictive capabilities in our software, we're not yet there to the moment in which we're always capable of predicting what the next best network is going to be. And that's why we have a multi-modem architecture. The spoiler that we gave at the beginning of this recording is actually that then over the next 18 months, we're going to be having quite of a big effort. It's a multi-million investment that we will be making on defining the world's most advanced network predictivity engine that exists. And so our output that we expect from that is to go to a predictive capability so advanced and, so let me say, reliable, that we will actually be able to not only serve our customers that have a single modem deployment, talk about new car manufacturers, talk about laptops even. Let's not even mention smartphones if we don't have to, but we could. And then eventually maybe even having a global version with a single modem approach. Because once we know which one is then going to be the next best network in 300 meters from where you are, or in 1 kilometer from where you are, or where you're going, then maybe having a second modem for resilience becomes less relevant. And it would become relevant only for better performance in that case.
So throughout the episode, we talked about cellular, satellite, Wi-Fi, all the different inputs into our solutions, and also a lot of different use cases that may need different approaches to really give the perfect internet that caters specifically to the needs of our customers. So to wrap up this episode, we can confidently say that Stellar is a one-stop shop for the perfect internet, whether it's on the move or for ubiquitous connectivity of distributed assets. So with any sort of solution, doesn't matter if there's an infrastructure that is lacking or whether it's about managing multiple contracts for multiple network operators, whether it's cellular or satellite, we are the ones who put it all together and who manage all of those things so that our customers don't have to worry about doing everything independently and individually. It's all just coming as one solution. So let's wrap up this episode today, where we talked about just how bad internet is and where we dived in a little bit more about GLOBBLE, one of our main solutions. Let's do some takeaways for this episode. Would like to start?
I can start actually. I would say that, and it was also a massive learning for me when I joined Stellar, solving the problem of bad internet on the move, it's really not a matter of launching another infrastructure. It's just a matter of using the ones that exist.
For me, the biggest takeaway from today's conversation is the fact that at Stellar, we enable a lot of amazing and life-saving use cases, which I'm very happy about.
For me, my takeaway from today's conversation is not only that I'm proud of the tech that we're bringing to the market, and like you said, Dursun, enabling a lot of interesting use cases, but also I'm happy about our commercial approach that we have to this. Like you said, Simone, the price is very accessible. So it means that we're able to bring in companies that are maybe smaller and then grow with them. Mm-hmm. And through that, we're able to see GLOBBLE as the access point for perfect internet. And that's something I'm really happy to be part of. Thank you for listening to today's episode. And don't forget that in 2 weeks, we're going to have episode 4 out. Don't forget to follow on your favorite podcast app and turn on your notifications to make sure that you always get notified when a new episode comes out. Thank you.
Bye, everyone.